Okay, now members, let us come to ladders. We're going to start with the simple problems as we move to more simple problems. Okay, so let's start with this one. A uniform rod, the moment here I want the uniform, it means that the weight is going to act in the middle of that rod. AB of mass 8 kilograms and length 8 meters rests with its upper end A against a smooth vertical wall and end B on the smooth horizontal surface. The moment here the word is smooth, you don't have friction. First of all, a light horizontal spring with one side attached to B and the other end to the vertical wall keeps the ladder in equilibrium inclined at 60 degrees to the horizontal. If the spring and the vertical wall are perpendicular, find the normal reaction of points A and B and then the tension in the string. So we draw a goal sketch, a simple sketch here. This is going to be my vertical wall. I'm going to be having a horizontal wall. So there is a ladder which rests its part A, its end A. Of course, this vertical and horizontal, they are going to be perpendicular. So let me call this A. They are telling us that A is resting on a smooth vertical wall and B on a smooth horizontal surface. So this is our horizontal surface. That is the first case. Now you look at that diagram there so far. Is there contact? Yes. If there is contact, there is reaction. We have reaction here at A. Do you have contact here? Yes. We have reaction at B. With ease. These are very simple things. You are done with that. What was the length of the rod AB? The length AB was 8 meters. As simple as that. Was it having weight? Yes. Is it uniform? Yes. It means that the weight is acting in the middle. So here we have our weight acting there, which we are going to say this weight is going to be. Let me even make it so that it can be as long as possible from there. That's going to be my weight. We get now 18 times E. That's what we get. That's how we get the weight. That's that. Now we have a spring which attached to B and then to the vertical wall. Of course, because this ladder wants to slide, there is going to be tension. So our spring from here up to here, we're going to have tension active in that direction. As simple as that. Now, this string is keeping this ladder in equilibrium, inclined at 60 degrees. With ease, you indicate that. Are we done? Almost. So now, they want us to get this reaction, this one, and then that. As simple as that. We say the reaction is always perpendicular to the surface and the point of contact there. That you can see there. Okay, so now it means that what is the easiest thing to get? It's very easy to get R and B if we consider, I would say, if it's in equilibrium, it means that the forces are equal. Upward forces are equal to downward forces. So the easiest thing to get first is the R reaction at B. So upwards, we have R at B. It's going to be equal to the downward force, which is 18B, which you can give as 18 times 9.8. So our R and B here is going to be 18 times 9.8, which is 176.4 Newton. I have R and B with ease. And I'm done with R and B. What happens after? I resolve now also horizontal. If I resolve horizontally, you see we have that force, we have RA. Is there an horizontal force? Yes, this one is equaling to T. I don't have this, I don't have this. Now, you see that this rod here, there's nothing like a force, it's just a rod. That's why you can't resolve anything based on this angle. This angle is just helping us to get the distances, this one and this one. So I call this one equation 1. Now, I need to get the values. Now the only option left is take moments. We have A, we have B. The question is, where do we take moments? Because where we take moments, it simplifies the question. Now, to know where you're going to take moments from, look at A, look at A, look at B. Where do we have many forces? We have many forces at B. So now we take moments at B, as simple as that. So taking moments at B, let me take them clockwise. Now, you see, if I have B, it means that now any force that is coming out from B, its moment is going to be 0, because at B there is no distance, and so the moment is given by the force times the perpendicular distance. So at here, any point coming from here or coming from here, its perpendicular distance is 0. That's why you have their moments as 0. So you can empty that now. To start them, this one is going anti-clockwise, and we are having R and B times 0, because we don't have perpendicular distance. Then it's this one from here. We have also, for it is going to go clockwise, but anyway. Now, you see, going clockwise, we have only this force. The rest, we also have, you see, at B, this force is also going to go anti-clockwise. So I have plus 18D. And the question is, what is the perpendicular distance for this 18D? Now, if this from here to here is 8, and this weight is acting in the middle, means that this one is going to be 4 meters, and this one is going to be 4 meters. Now, if I have this angle and I need this distance, how am I going to get it? You can say the perpendicular distance I want from here is that is the perpendicular distance. So, I will draw this diagram here. This is my 60. This is 4 meters. This one 100. So now, you see that if I have this angle and I have this, I can get this. This is going to be, the way this is adjacent, so it's going to be now 4 cos 60 meters. This is opposite. It's going to be opposite, goes with sine. It's going to be 4 sine 60 meters with ease. So now, you have the perpendicular distance from here up to here. It's going to be 4 cos 60. That is the moment there. It's going to be equal to 2. Now these ones, remember we are using the principle of moment. That clockwise moments are equal to the anti-clockwise moment. They are sum. So now these are the ones which are going anti-clockwise. Now when they become, this one's going clockwise. Clockwise, we have this one as the major force there. So it's that our Rn, that is the force, what's the perpendicular distance? Now, from B, the perpendicular distance from here is the distance I want here. So I need this distance. So I come and I draw now, still that triangle here. Hope you can see this is 60. And this one now, the whole is 8 meters. You can see that this is opposite, so this one is going to be 8 sine 60. And this would be 8 cos 60 with ease. So now I have this is going to be in meters, even this is going to be in meters. I have this distance now and I have that, but I'm going to get the distance from B to this. The perpendicular distance is going to be from here up to here, the same as from here up to here. But this is that it's going to be 8 now sine 60 meters. So meaning I have the distance as 8 sine 60. I have that. So this is 0. And then we have, of course, this t is also going clockwise. Then plus t times 0. Why are we multiplying with 0? Because from here it doesn't have any perpendicular distance from B. That's why I'm multiplying it with 0. So here I have 18d times 4 times a half, or 60 is a half, equaling to my Ra times 8 times root 3 over 2 sine 60. Okay, you see that this one is going to be 1, this is going to be 2. And then we have anything like this 1, like this 4. So from there, allow me right here, this is going to be this times this, we are going to have 36. 36, or you can see it's cancelling, so this is cancelling with this, but don't rush. We have 4 root 3 Ra, which you can every simplify. So from there, our Ra is going to be 36 times 9.8 over 4 root 3. So our RA from there is going to be equal to me I'm getting 50.923 newtons, and that's going to be my answer. Then you see, you say that our RT is equal to RA. If I that even 90, it's going to be 50.9223 newtons with ease. So what are we missing? We have reaction at B, have reaction at A, have the tension. Now, I want you to go and try. You are going to get the same answer, but you try to get moments at A. This is going to be a bit tedious because you see the Bernoulli distance from A here. You do need to put now it here. So try and get it. You're going to get the same answer. But the idea is always take moments where you have many forces from so that you can reduce on that body. So that's it. I wish you well.